Hello, this video is a demonstration of simple postmortem debugging of a QB64 program using a Dr. Watson log. It is not a general debugging tutorial, but just a demonstration of this particular technique. And it is explained or discussed in this forum thread. Hopefully you will have read through this thread and also this sample program that we will be using. We need a map file. The map file needs to match the executable that crashed. We will recompile the program to get the map file, and since it must match, hopefully the program won't have changed between the time we can create the map file and the time of the crash. Now, if it's a consistent crash, a predictable crash, we can always just crash it again. But if it's an intermittent crash, well then hopefully the program won't have changed so that we can get a reliable map file. So I will recompile the program. And I'll try to be as brief as possible in this video. I'll try, I won't necessarily be able to do it. I need to find the recompile.bat file. Sort them by date. Use the most recent, which is in the temp folder. I didn't have multiple copies of QB64 open at the time. Did not have, that is. So I create a copy of recompile.bat and edit it. And at the end of the G command line, I paste this. This tells the linker to create the map file. Save it and run it. So we have a map file. We will need the map file. We will need the program, and we will need the Dr. Watson log. Now I'm going to delete the contents of the log. You wouldn't do this if it weren't a reproducible crash, but this is a reproducible crash, so I'm going to delete the log and crash the program again. And we'll have a clean log. With just this one crash. So you have the name of the program that crashed. You have what type of crash it was. It was an access violation. And you have multiple threads, but we want the one that had the fault, which was this one here. So these are the registers. Now, Dr. Watson cannot find the symbol files for any of these files, or couldn't find symbols, so it's using the export symbols from the various DLLs, and that's fine. That's all we need from the DLLs. From our program itself, there are no export symbols. There are no symbols, period. Even if we had taken that -s out of the command line, which strips the symbols, those are not the kinds of symbols Dr. Watson would be able to use. So one way or the other we need the map file. That's why we've created the map file. So this is a disassembly of the area around the faulting instruction. And you can see this was trying to read from memory address 0, and that's what caused the fault. This is a stack backtrace. This tells us which functions had been called. This is the function that crashed, and that's the one that called it. That's the one that called that or the previous one, and on. So it's a chain of functions basically. So what we'll do is we'll use the map file to try to resolve these ones that Dr. Watson can't resolve for us. So we know the one that crashed is MSVCRT's memmove function, and that makes sense if you've looked at the program. If you look at the documentation for memmove, the first parameter is the destination, the second parameter is the source, and the third parameter is the number of bytes to copy. So, and these are the parameters here. Dr. Watson just gives us 3 parameters for each function, regardless of how many parameters the function actually had. So whether it be more or less, it's always going to give us 3. In cases where the function actually used less parameters, well then the rest is just garbage. So the first parameter is the destination, and that's a valid address within the X array. That's the source, which is 0, that's obviously not right, and then the number of bytes. So what called memmove with those parameters? Well, we can see on this stack backtrace what called it. So we need to resolve this address. Let's open up the map file. And we need to, actually I'm going to maximize it just for a minute. The image base is 4 followed by 5 zeros. Let me see if I can find it there. Yes, there's the image base. So basically we're just going to ignore all of that, and we're just going to use the right 4 or 5 places, whatever. In this case it'll be 4 places. But basically we're subtracting the image base, and we'll start basically on these here. Let me restore it. Okay, so we need to resolve this address. So what's the nearest address in the map file that's below that number? And it would be it'd be that one right there. So funcPicky is what called memmove. If you look at the program, that makes sense. FuncPicky takes an int pointer, so this right here is a pointer to an int on the stack. So let's look at the stack raw dump here. FEB0 would be right there. These start at 8, unfortunately. I wish they were to start at 0, but they don't. So the parameter was 6. If you look at the program, if the parameter was 6, and that's why this line got executed. So that makes sense. What called picky? Let's go one further back on the stack backtrace. So what's this function right here? 830E would be that one. That's the one closest before, closest below. That's funcD, which takes an int pointer. So this one right here is a pointer to the stack, a pointer within the stack. FF30 2. So that was funcD, I believe, was called with a parameter of 2. 2 times 3 is 6, so that's why picky got called with a parameter of 6. Let's try taking it back some more. This one here, 7EE0. 7EE0, that would be sub A. Oops, sorry. This is the one nearest below it. So sub A, which also takes an int pointer. So FF30, and that's also a parameter of 2. And if you look at the program, and that makes sense. Here's where sub A is called with a parameter of 2. It just takes that, passes it on to D, which multiplies by 3, passes it on to picky, which if it's 6, it calls memmove with a parameter such that would cause a crash. So there we go. And then further up you've got SDL, 2 SDL functions, and then MSVCRT in thread X on the stack backtrace, and then that's pretty much that. Like I said, I tried to be brief. Hopefully the video will come out right. The previous one didn't. Okay, well that's set. Thank you for watching.